All right, guys, here we go. First lesson on chapter 10, probability. This is going to be our final chapter of the year. So here we go. But it's also a super important area of math, especially if you do anything beyond this class. You're always going to see probability stuff come up. So a few things I want to go through with you, a couple diagrams. So first things first, just think of basic probability and how we find it. So we're going to start simple here and kind of work our way up. So I'm on page 283 of the journal. So just think basic flipping a coin. If I were to take a single coin and flip it, right, what would we say? Say, what's the probability of getting tails? What would we say? Well, we would say 1 out of 2, but I want you to think of what those numbers represent. Okay, and so the 2, this is kind of the first key term that we come across here. That 2 represents what we call our sample space. So your sample space is the set of all possible outcomes for that experiment. So whenever we think of probability, that's always what goes on bottom, is the total possible outcomes that we could get for the event. The guy on top is basically how many ways can you get what you want. So if we were to say, what's the probability of getting tails? Well, if we flip a coin, obviously only one side represents tails, right? Because this side, our sample space, is either heads or tails. So 1 out of those 2 options represents tails, right? And so that's our basic probability. So what if we were to flip 2 coins or 3 coins or more? How could we build on this idea right here and get something that's a little more complicated than what you've seen in the past? So I want to introduce you first to a diagram called a tree diagram. This is one that becomes really, really helpful for some of the tougher ones. You wouldn't do it for something as simple as this, but once you start tossing 2 coins or 3 coins or maybe a couple dice or something like that, that's where we start getting into something that would help have a tree diagram. So I'm going to kind of do this down at the bottom because I don't know if this will be enough space right there. So I'm going to bring this one down to here. So we're not actually doing this one right now. This is just for introducing you to the tree diagram. So here's how a tree diagram works. So if we were to say, I were to flip, let's just start with 2 coins. Okay. So the first set of branches we lay out here represents the first coin flip. And the number of branches you draw depends on how many items are in your sample space. Well, as we just saw up above, if I flip a coin, there's 2 possible outcomes, either heads or tails. So these 2 branches represent the 2 possible outcomes from my first coin flip, right? It is either heads or tails. So these 2 branches, this first level represents my first event. Well, what if we flipped another coin, right? We have another heads or tails possibility here. So we're going to build another level of branches here to represent the second coin flip. One thing we have to consider on this, though, is, well, what this is following something that has already taken place. So if we were to get heads on the first coin, this is what could happen on the second coin. I could either get heads or tails. Right, so that's a possible scenario. Our other possible scenario is, well, if I got tails on the first coin, what could happen on the second coin? And again, I could either get heads or tails. So if you were to trace your way through the branches, you're going to see the possible outcomes that we could have for tossing 2 dice. So if I were to go across the top branch, we could say, well, maybe I get heads on the first coin, heads on the second coin. So here's one possible outcome when I toss 2 dice. We could get heads on the first coin, tails on the second coin. So that's an option. Maybe tails on the first coin, heads on the second. Or we would say maybe I get tails on both coins. So if you look at these 4 options here, that represents our sample space for tossing 2 coins. So there's 4. There's 4 possibilities here. So if I were to ask you, what's the probability that you toss 2 coins and they both are tails? Well, you can see 1 out of the 4 represents that scenario. right? And so you could say, well, what's the probability that the first one is tails, but the second one is heads? Again, that would represent 1 out of the 4 cases, right? That we get something like that. And do notice on this that the order does matter. So heads and tails is not the same as tails and heads. Even though it's kind of the same results, they're coming from different coins, so we treat them as different results, right? In a case like that. So what if we were to toss a third coin? So I'm going to erase these 4 outcomes just so I can show you what if we were to throw in another coin. Right, and so we extend our tree here. So if we were to throw a third coin, again, it's either heads or tails, and I have to show that off of the 4 possible results that we've already had. So in the third coin, so again, I could have had heads on the first one, heads on the second one, and then what would be the possible outcomes for a third coin? And of course, again, it's either heads or tails. And we're going to show that for all possible cases here. So again, if I went down this branch, it's either heads or tails for the third coin. From here, either heads or tails. Or we go from here, heads or tails. Right? So this is what it would look like if we toss 3 coins. And again, you see if I go across all the branches, I'm seeing all these possible scenarios. Maybe all 3 of them are heads. So it could be heads, heads, heads. Could be heads, heads, tails. I'm not going to lay out all 8 of these, but there are 8 possible outcomes if you were to flip a coin 3 times or flip 3 coins, same thing. And so as we look at these 8 results represent the sample space for tossing 3 coins. So tree diagram is a super important diagram that really helps us with some of the tougher scenarios like this. One other thing here that I wanted to show you with dice. With dice, we get another really important diagram, but again, you wouldn't use it for a simple one like a single die. You would only use it if you had 2 dice, right? As we would use this diagram. So again, let's start simple. So if I only was tossing a single 6-sided die, right? And we said maybe what's the probability of getting a 4, or what's the probability of getting a 2, right? We would say, well, it's 1 out of 6 because if I toss a dice, we know there is 6 faces on a die. And so that way, if I then say, what's the probability of getting a 4? Well, we know 1 of those 6 is a 4, right? And that's that basic probability that I know you guys have seen in the past. So let me show you with 2 dice. So, and this is where we get a diagram called the lattice diagram. So a lattice diagram is really just like an XY grid. That's all it is. So it works really well with 2 events like this. So one is going to be like our X column, and the other one's going to be our Y column. So I'm going to have my Y column represent the sample space of this die right here. So it could be a 1 or 2 or 3 or 4, 5, or 6. So those are the 6 outcomes that could come from this guy. What about the second die? So here are the 6 outcomes that could come off of the other die. So I'm using like the y-axis to represent the first die, and I'm using the x-axis to represent the second die. So within this little grid here, you're actually now seeing all 36 possible scenarios for tossing 2 dice, right? This is a 6 by 6 grid. So it could be a 1 and a 1, a 1 and a 2, 1, 3, 1, 4, 1, 5, 1, 6. It could be 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. So I could keep going, right? But this is going to represent all 36 possible outcomes for tossing 2 dice. And I want to show you something real quick. So whenever you toss 2 dice, right, then we would always say it's going to be out of 36. Because as you can see by the lattice diagram, that there are 36 possible scenarios when you toss 2 dice. But having this diagram now makes it really easy to answer a question. So if they were to say, what's the probability of getting doubles, right? Like a 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. Right? So what's the probability of getting doubles? Well, just count them. Right? There is 6 out of the 36 are doubles within that diagram. So this becomes really helpful for answering questions on 2 dice. So let me flip the page here and take you to the spinner. Again, when they say list the sample space, that just means list out the total possible outcomes. So I would start by listing a 1, a 4, a 5, a 5, a 3, a 2. So you do repeat them. You would just list them all. Okay, so that would be the list of our sample space. If you listed all of those, how many are there? Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 options, and I would list all 12 of those, even though some of them repeat as my sample space. So here's sort of the point of using a sample space. If I really listed them all out, so I'm just going to start with the 4. So 4, 5, 5, 3, 2. 4, 3, 5, 3. 2, 5, 1. So to answer this question, we can see that there are 12 options, total number of outcomes. So whatever my probability question would now be is now going to be something out of 12. So if I said, what's the probability of spinning the spinner and landing on a 5? Well, there are 1, 2, 3, 4 of those. So 4 out of the 12 would be my probability of landing on a 5, right? And so that's just that sort of basic probability idea. So sample space, really helpful to just have your sample space laid out in front of you to answer questions like that. And let me turn the page again. Keep this moving here. So 2 last things I want to show you. So I'm jumping to page 286. This is on page 286. So we're going to look at number 2 here. So we have 2 events. So I have a spinner that goes 1 through 5, and I have a 6-sided die. So there's 2 events. So remember what I showed you before with the 2 dice. When you have 2 events like that with multiple outcomes, a lattice diagram becomes really helpful. So I'm going to let my y-axis represent the spinner that goes 1 through 5. So 1, 2, 3, 4, 5. And I got the 6-sided die. Oh man, I didn't leave myself enough room. Hold on. I'm going to let the 6-sided die represent my x-axis. So I'm going to do it right here. So I'm going to do the 1, 2, 3, 4, 5. That's my spinner. I got the 1 through 6 as my die. So first things first, how many total possible results are there with these 2 events? Right? Well, if this is a 5 by 6 grid, we know 5 times 6 is 30. So any probability question that you would be asked related to this scenario would be something out of 30, right? Since there's 30 options in my sample space that I'm seeing right here. So one other thing I wanted to show you, let me go down to number 4. By the way, I wanted to mention on this one before I give you the last example. In this problem, they were asking you to find the possible outcomes and to actually list them. There's no way on earth you would want to list all 30 possible outcomes. That's not something we would do. So by having this lattice diagram, I now am seeing all 30 possibilities right here in front of me in this little grid, which makes a lot more sense than just coming up with a list from left to right. Right? There's no way we would do that. So we would use this. This would be way more efficient rather than actually listing them all out. That's one of the reasons I made up a worksheet for you guys to do for this assignment rather than do the book problems, because they had kind of some ridiculous questions like that. So last one, there's a little probability about pizza here. So consider it in a grid like this. What would be our total possible outcome for this? So you can see that there is a total of 90 options. If I add all 4 of those together, it's going to be out of 90. I simply list the one that matches the description that they're giving me, which was the thin crust with pepperoni. So 34 out of the 90 fit that description.